This is half subtractor. You can see one XOR, one AND gate is constant. One inverter is also required. So first I have to execute one inverter gate. Inverter. I have to execute one inverter, for which what I will do, I will create a new verilog module, inverter switch level modeling, inverter switch level modeling. Inverter switch level modeling. I have executed this yesterday 7:50, so you can believe it, it will work. Okay, I will make this inverter switch level module as a top module. I have to select this option. Only then inverter top level module I can make. Now check syntax for the inverter. No errors. Okay. So inverter, how it will be, already I explained you. This is the inverter. Only one PMOS and one NMOS. For PMOS, input are X and VDD. Output is F. Okay. For PMOS, you can see. For PMOS, you can see X and VDD are the inputs. Output is F. For NMOS, ground and X are the inputs. F is the output. Okay. For NMOS, ground and X are the inputs. F is the output. So other things, supply 1 means VDD, supply 0 means ground. Input is only one input X, output is only one output F. This is the basic definition we have given for inverter. No errors, successfully completed. Now I am going with test bench for inverter. I am going with test bench for inverter. So INV underscore TB I will take. And this is for inverter, properly select. This is for inverter, I am creating test bench. And already you can see only one input is there, X equal to 0 and X equal to 1, hash 100 nanosecond. Okay, X equal to 0, X equal to 1. And then stop, dollar stop. This is about inverter. Select the test bench, execute the simulation model. Full view. You can see when input X is 0 means output is 1. When input X is 1 means output is 0. Inverter in switch level modeling is working. Now what I have to do, I have to execute half subtractor. For half subtractor, I have to invoke one XOR gate, one AND gate, and one inverter also. So I will go with a new program. I will go with a new program, which is half subtractor. Okay, half subtractor. And XOR completed, AND gate completed, inverter also we completed. Now we are using structural model for half subtractor. You can see here one XOR gate I am calling, one inverter also I am calling, and then one AND gate also I am calling here. Okay. So now in this half subtractor, at the inverter output, one temporary variable is there. So that I am taking as A bar. Okay. If A is the input for inverter, inverter output is A bar, that will act as input for the next AND gate. So that A bar is the output. For AND gate, A bar becomes input, B also input, and borrow is the output. You see here for both for XOR, A, B are the inputs, difference is the output. Okay. So A, B are the inputs and difference D is the output for XOR gate. Next, for inverter, A is input, A bar is output. So for inverter, I am giving A as input, A bar as output. Same order you have to give as in the submodule. Inverter verilog program, first input followed by output. Same thing you have to do in the half subtractor also. Same thing you have to do in the half subtractor also. Input followed by output only you have to give. The order must be followed same. Okay. Similarly, AND gate. So AND gate, the inverter output is A bar. A bar and B are the output and borrow is the output. Okay. A bar, B. A bar, B are the inputs for AND gate. Borrow is the output. So now I will try to make this half subtractor a stop module. Half subtractor I am making a stop module. Check syntax. Check syntax. No errors. Okay. So now I am going with half subtractor test bench. I will create test bench for the half subtractor. So HS underscore TB, half subtractor test bench. So here you have to properly select for which one you are creating the test bench. I will close the other files. We understood what all we have done. XOR gate, AND gate we have used. And this is previous program, half adder. Inverter also we are using in the half subtractor. Now this is the test bench for half subtractor. Test bench for half subtractor. A, B are the inputs. So 2 inputs means 4 combinations are possible. 2 inputs means 4 combinations are possible. 20 nanoseconds delay I will take. And then 4 combinations I told you. 0, 0, 0, 1. 1, 0, 1, 1. And then stop we have to put. Stop we have to put above the end. And you see the truth table of half subtractor. Truth table of half subtractor. If input 0, 0 means difference and borrow are 0, 0. Okay, first we will execute the test bench. I will select the half subtractor test bench and then execute this. So when input are 0, 0, difference and borrow both are zeros. Input 0, 0 means difference and borrow both are zeros. Input 0, 1. Input 0, 1 means 1, 1. Difference and borrow both are 1, 1. So input 0, 1, difference and borrow both are 1, 1. Input 1, 0. 1, 0 means 1, 0 is the output. So next combination, input 1, 0 means 1, 0 is the output. So last combination 1, 1. Input 1, 1 means difference and borrow are 0, 0. Input 1, 1 means difference and borrow are 0, 0. Okay. So half subtractor is working. We have done with the structural model. We have called one XOR gate, one inverter, and one AND gate in the main program. Okay.